Good morning, everyone. It is so good to be back in person, seeing lots of smiling eyes, at least. Anyways, let's get started. So, on Friday, October 19th, 2007, GitHub co-founder Chris wrote the first commit of github.com. Less than an hour later, he committed the first style sheet to the GitHub codebase. It was just a couple of lines. It had a simple reset of margin and padding, hard-coded some colors for the body, and styled some links. About 2 months later, there were only 238 lines of custom CSS. After another 4 months, that number increased by an order of magnitude to around 2,000 lines. This is right around when GitHub launched to the public. And then after about 5 more months, the amount of CSS doubled. So since then, our CSS continued to grow by about another order of magnitude. We eventually plateaued right in the neighborhood of about 40,000 lines for the past 8 years or so. And thank goodness, if you look at this graph, you can imagine where we'd be today if we had continued on that trend. So what happened when this graph stabilized, right around 14, 15? Well, we made a design system. It's called Primer, and it provides tools for building UI, what we call the GitHub way. And it's no coincidence that we open sourced this work in early 2015. So we created Primer, and it stabilized how much custom CSS we had. But unfortunately, we never finished the work. We didn't really address those 40,000 lines of CSS that continued to stick around. So that's what my talk is about today. I'm going to talk about the problems we've had with that existing CSS. I'm going to share some of our successes and mostly failures in addressing them, and how those lessons kind of grow together to inform our vision for the future of how we're going to build UI at GitHub. But first, hi. Hello, everyone. It's, again, weird to see you all in person. My name is Joel. I live in Colorado. And as a Colorado resident, I'm fulfilling my contractual obligation to show you a picture of me and my dog on the top of a mountain at sunset somewhere. So this is my dog, Captain, and I above Palisade on the western slope of Colorado in an area called Grand Mesa, which has hundreds of lakes over a mile above sea level. It is a wonderful, quiet place in this world. But as some of you know, I actually don't really live anywhere right now. I am currently displaced. My wife, Caitlin, and I lost our home a couple months ago in some really terrible wildfires in Colorado. It's been a really difficult couple of months. Luckily, I actually wrote this talk 3 days before our house burned down, so I was good there. But I wouldn't really be standing here in front of you without the very real support I've gotten from friends, family, and actually a lot of people in this room. I will say that I know way more about homeowners insurance. And in fact, I was actually thinking as a joke, I would just give a talk on homeowners insurance instead today. But figured you came here for Ruby and Rails content, so we're going to stick with the program. But if you have any questions about making sure that you are in good shape if catastrophe strikes, come see me after. Anyways, so as for my role at GitHub, I'm a staff engineer on the design infrastructure team. We're a group of designers and engineers that build and maintain Primer, our design system. And I guess this is probably the most appropriate time to mention we are hiring. If you're a Rails engineer who knows some things about accessibility and has done accessibility work before, please see me. We really need someone who's good at it. Anyways, what was I talking about? Design systems. So let's start with the definition. So I like this one from the Nielsen-Norman group, and I will do this once. I will read the slide to you. A design system is a set of standards to manage design at scale by reducing redundancy while creating a shared language and visual consistency across different pages and channels. Reducing redundancy for the sake of visual consistency. It really is just another way of saying that design systems are abstractions. They take things that we do many times and standardize them. But like most abstractions, design systems are only effective if they're actually used, which is a great segue into talking about our custom CSS problem. So if we look back at our graph of custom CSS, there is still at least 40,000 lines of it in our monolith. 40,000 lines. It's incredible. And it's 40,000 places that we aren't using our design system, which is really how I feel about it. Custom CSS represents where our system has fallen short. That every single one of those lines is a place we could have used our design system, but we don't. So you might be wondering, why am I bringing this up now? It's 2022, right? Like, what makes this year so much different than all these other previous years that this code has been around? The reason is that our custom CSS has become a real liability to our company, like most technical debt does eventually. One of the biggest problems has been being able to make efficient changes due to this problem. So if we look back to our graph, things stabilized around 2015. But if you're really thinking about the history of our company, our user interface did too. So here's what an example repo I went into the Wayback Machine and looked at the Node.js repo because it's been around for so long. So we'll go through a quick little tour of what Node.js looked like. So here's 2015. 2016, we moved the tabs to the top. In 2017, we made maybe our most controversial change ever. We made the header dark. I don't know if you remember, Twitter was on fire with this one for a while. In 2018, I can't tell the difference. Can you? Same for 2019. In 2020, we did a little facelift and made things a little wider, made it a little, some visual tweaks. And things have remained pretty similar since then. And honestly, I don't necessarily think this is a bad thing. I love that we're kind of a constant in this very ever-changing world. And let's not forget that through that timeline, we happened to sell our company to Microsoft for like $8 billion, I think. So obviously, we're doing a couple of things right. But to be honest with you, this outward-facing stability really masked a lot of difficulty that was going on below the surface. It reminds me of a favorite metaphor of how when you see a duck swimming in a pond, it looks beautiful and peaceful. But if you were to look underwater, it's actually a vigorous, wild mess of flippers and fins. So one example of this is when we shipped dark mode, which would actually be a great talk all in and of itself. But it took us almost 2 years of engineering work to ship this feature. And a good chunk of that was because our custom CSS was such a liability that we had to carefully go in and make it so we could change our color scheme on the fly. So this is what I mean by it being difficult to make changes efficiently. And what really hurts me is that we have many more ideas for improving the look and feel and really the way GitHub works, but we really struggle with being able to justify the effort because of how costly it is to make those kinds of large sweeping changes to our code base. So in a similar vein, it's also been difficult to make changes to our CSS safely. There's nothing like the sting of a good visual regression, especially when you only find out about it on Twitter, as we often do. So in this case, you can see actually several bugs. One is the copy button's icon. It disappeared when you clicked on the copy button, and the button wasn't even the right size in the first place. This is but one of many bugs that we introduced while trying to do some refactors, cleaning up that custom CSS. And when I really think about it, the root of the problem is that bad design doesn't break CI. These visual regressions are really hard to catch, even with tedious manual testing. Sometimes they're buried below multiple clicks into an interface, or maybe someone has their screen zoomed, or they're on a particular pixel width, and our responsiveness doesn't work quite right. And all those assumptions are based on even knowing what pages might be affected by the change you just made. So say I have a single CSS file, and I have an index template that uses it. If I change that style sheet, I just have to make sure that one file still renders correctly. But what if there are 3 pages that use the same style sheet? What pages do I need to verify? It depends on what pages use which rules from the style sheet, and that can be really hard to figure out. But then what happens when there are dozens of pages that use the same bundle, or hundreds, or in our case, thousands? These are the things that ultimately keep me up at night. And what happens is that there's a real human cost to this, because when you can't make changes safely, it really starts to break down your confidence in your work. So those are some of the problems. Now let's talk about our successes and, like I said, mostly failures, and addressing them. So one of the greatest sources of comfort for me as I've taken on this problem at GitHub has been Jeff Atwood's 2007 blog post that some of you might have read called Falling into the Pit of Success. And in the post, Jeff describes how working in C++ is like walking along the edge of a bottomless pit. And actually, I lied. I'm going to read another quote. That's the problem with C++. It does a terrible job of protecting you from your own worst enemy, yourself. When you write code in C++, you're always circling the pit of despair, just one misstep away from plunging to your doom. This really struck a chord with me. CSS was my pit of failure. But Jeff's article was called The Pit of Success. So he continues and says, if we design our applications properly, our users should be inexorably drawn into the pit of success. Some may take longer than others, but they should all get there eventually. What we needed to do was make working with CSS in our giant code base a pit of success. So over the past year, we've tried a couple of different things. We worked to better understand and communicate this problem through good measurement. We've tried splitting our bundle up into functional areas. We've experimented with various encapsulation techniques for our CSS, and we've looked at ways of diffing the computed styles in the DOM. So let's start with measurement. So when I started this project, I had really what I just call a bad spidey sense, as we all often do when we're looking at code we don't like. And my hunch was really twofold. One was that we had a lot of technical debt, and that it was actually getting worse despite very real efforts to remediate it. But the problem with having a spidey sense is that it's often not enough to convince other people, let alone people like your manager, to understand the problem and give you the resources, whether it's time, whether it's maybe even other people's time, to figure it out. So this work reminded me of one of my favorite quotes, which is that premature optimization is the root of all evil, maybe one of the most famous quotes in software engineering. But the way I think about it in this context is that optimization without an end goal is a fool's errand. And this really came from a question my manager asked me when I told her about this work, and she said, that's great, how will we know when we're done? So at our scale, as you can imagine, there's always something more to do. You could put hundreds of engineers loose and have them refactor code at GitHub, and there'd still be more. So how could we measure the problem so that we'd have something to optimize against? And like I said, maybe to know when we're done. So we had to tell the story behind those 40,000 lines of code. So I went to my colleague John, and I said, hey, John, how do you think we could use Datadog to measure our custom CSS? And John is really good with Datadog, and he came up with this absolutely glorious dashboard that I love so much. What I think is really great about this is that basically what we do is on every master build, we run a script that analyzes our CSS, and it pushes a ton of statistics up to Datadog. And what this really is it's like a living, breathing view of how effective our design system is in basically real time. So one thing I really love about this dashboard is that it's so effective at creating an emotional response. And it does it using one number. And that number is the lines of custom CSS added in the past week. This number has been hundreds of times. It also turns green if it's negative, which is pretty cool too. What I love about this is that it takes an incredibly complex problem and simplifies it down into one number, while it isn't a perfect measurement, really helps people understand like the root of the problem in the current moment. John also found some other ways to show the extent of our recent changes. He set up this graph that shows where those lines of custom CSS were added. So for example, a lot of custom CSS was added around tooltips in the past week when I was taking the screenshot, and that allowed us to actually go in and look at that code and talk to the team that was doing it. So in a similar measure, we also track where our linters are disabled. Much like Rubicop, where you can disable a specific line, a linter for a specific line, we track those disables for stylelint as well. We also track things in the bigger picture, like our most disabled linters overall. This helps us understand like what fundamental parts of our system might be lacking. So like, for example, our most common override is in spacing. So this might point to the fact that our system doesn't handle all the spacing things that we need to do in the application. We also track violations by code ownership. So we have hundreds of teams at GitHub, and this graph allows us to show for example, like that the marketing team, did not switch my slide. Basically, there's a lot of CSS that is used by our site design and site engineering teams, which are effectively our marketing team. This has actually led to some conversations around whether we might need to build a design system for them, which is something that we're now working on. And sometimes it's as simple as just measuring the number of lines in a file. This graph shows how our settings and discussions styles are some of the largest in the code base. And while this might be simplistic, this actually has turned out to be one of our more effective measurements. And I can tell you that this is effective because just a few weeks after John made this dashboard, I was in a planning meeting with engineering leadership in our part of the company, and there was a screenshot from his dashboard in our quarterly planning. So by measuring this problem that we were all just kind of talking about and complaining about, we made it actionable, right? We made it so that people could see, we could see the problem and help them understand the scale of it. So that's how we benefited from using measurement. Another way we approached this problem was by trying to split up our bundle. We're actually still working on this right now. It all started with this graph. So in addition to CSS being difficult to refactor, our bundles were having real performance implications on our customers. So if you go to a pull request page, and I think this is actually still somewhat true, only 3% of the CSS that you load on that page to view a pull request is actually used to render that page. Which basically means that you're downloading about 400 kilobytes of CSS and parsing it, which is another cost, it's completely unnecessary. So what was really difficult about this is that because this file was like one big bundle, we ended up breaking the cache on that almost every time we deployed because someone was changing something in that giant file. This ended up happening, we deploy a dozen or two times a day, and it was most of those deploys were breaking the cache. So going back to our diagram, the idea here was that instead of having a single bundle for the entire application, we figured we could replace it with a bundle of just the code we needed for that specific area of the product. And this is actually what we tried for these three areas: marketing, settings, and discussions. And we did it with a class method that we added to application controller that allowed for declaring which style sheet bundles should be loaded on a controller's actions. So this allowed us to, for example, move our marketing-specific styles to their own bundle and then only load that bundle on marketing pages. And we did the same thing for our settings pages, and then ran into some trouble as we started to split out the custom CSS for our discussions feature. So if we go back to our diagram, let's just focus on the discussions part. As you might imagine, this is a very simplified version of what's going on in our code base. There are actually around 50 templates just in the discussions folder, many of them being partials. And those partials created a new problem, right? Partials are something that you write when they're meant to be, when you want to reuse some view code. So for example, people wanted to reuse the way we did reactions on discussions, so they would reference that partial, say in the template for showing a new release. This is now an actual bug that we actually shipped to production. But this template in a certain state didn't render properly because we had split out the bundle and only served that CSS with discussions, not on the releases page. So what happened then is that we were really hurt in our ability to use partials as intended, which is to reuse view code across our application. And that was really a problem because if we wanted to reuse it, we would then have to load that whole bundle all over again, and we're basically right back to having one central bundle of CSS. So this was a really tricky one. There really wasn't an obvious answer to this problem. And I can tell you that at our scale, a lot of my colleagues who are helpfully sitting up here up front will tell you, is that problems like this just honestly feel more and more common. Like, Rails no longer has the answer for all of our needs. Stack Overflow becomes a lot less useful. It's kind of a lonely existence, to be honest with you, and it can be hard. But one way we've approached these kinds of problems is to look across the broader web ecosystem for inspiration. Maybe we need to see what people are doing outside of Rails. And these days, a lot of innovation around how people architect UIs is happening in React. And honestly, it's really incredible. I find it really inspiring how there's just a ton of smart people really experimenting with new ways of handling the complexity of how we build web applications. So how are they handling this problem at scale? So here's an example from the React implementation of Primer, our design system. So don't need to get into too much details, but basically when we're declaring a component, we can say it's a style div that has this kind of pseudo CSS data structure that is kind of a hash. Anyways, we can, you can look up values on our colors object, for example, or our spacing object. But what's important to know about this is that instead of having a global CSS bundle, or bundles in the case of what we were just talking about, these styles are defined right inside our React components, right alongside the template. And then what happens at render time, this is literally what happens when you render the page, is that we generate a hash selector with those styles that I just showed in the JavaScript. That hash selector is then inlined at runtime on the page. And that architecture is called CSS and JS, and it has some really desirable benefits. One is often referred to as critical CSS. Critical CSS means that you're only serving the CSS needed to render a page. Said another way, if we go back to our graph, it would mean scoring 100% on this measurement instead of 3%. The second is encapsulation. So in the context of CSS, that means having confidence that a change will only make the effect that you intended it to. So looking back at our example from React, CSS and JS structurally guarantees that the CSS you write only affects the React component you're writing it for by generating those globally unique class names. So those things all seem pretty great. How could we bring them into our Rails app? So we started with a proof of concept. Our test case was the author's graph on the repository pulse page. How many people here have seen this before? Wow, that's actually more than I expected. I thought this was a kind of a dark corner of the application. Anyways, so this graph uses some custom CSS that isn't used anywhere else in the application. It is just on this page. But it was being loaded on every single page of github.com. So anywhere you went, you loaded the CSS to render this graph. So here's a slightly simplified version of the styles. We basically do some positioning. We set a height, set a width of any SVGs inside the graph, and set some colors and opacity. So the first thing we did was we took the class names, and we appended a random hash in our build step. And then what we did is instead of referencing that class name directly in the template, we wrote a method that takes the original class name and returns the hashed version using an artifact from that build step. This is sometimes called CSS modules. So just like that, we had encapsulated styles. But what about critical CSS? How could we ship that CSS only when it was needed? Our answer was View Component. This is kind of my thing. View Component is a framework that we built at GitHub with the goal of bringing some of these really great ideas from React into the Rails ecosystem. And I'll just gloss over it quickly, but in their most basic form, View Components are often pairs. They come with a Ruby file and an associated template. So what we did here is we just added a CSS file right next to the existing component files. And then we told our build pipeline to compile that style sheet into its own bundle, just for the component. So here's what it actually looks like in action. We have our graph at the top. We have our generated selector. We ended up just using the name of the Ruby class because Ruby classes are globally unique in our Rails applications. And then we have a link tag with our component-specific bundle, which means that we can render this component many times on a page, and the browser will just say, hey, I've seen that link tag before. I'm not going to reload and parse that resource. And what's awesome is that if you go to this page right now, this is in production. But it's not yet ready to be open sourced. That's something that we're going to be working on soon. So that's our experience with CSS encapsulation so far. This work is still, like I said, pretty experimental. But we think there's some interesting future. There's an interesting future for this kind of approach. So the next experiment we worked on was style diffing. So earlier I shared how we've been finding it difficult to safely make CSS changes, and how we often painfully learn about them via Twitter. The issue here is the nature of visual regressions. It can be difficult to programmatically determine whether a code change will result in a visual change. So said another way, CSS is really hard to test, at least effectively, because you really only know the result of the CSS you've written once you load a page in the browser. So one of the most common solutions people take, and people recommend to me when I tell them about this problem is, why don't you do some screenshot testing? And they'll recommend using a tool that takes screenshots before and after a code change and diffs those two screenshot artifacts. This is actually from Percy. This is a vendor that I've worked with in the past. It's a really great tool, and it works quite well, but it's generally a pretty manual process. You can actually see in the screenshot that there is a green approve button, which implies some level of manual intervention with these kinds of changes. So one day, I found myself debugging yet another visual regression, and I was poking around the Chrome DevTools to view the computed styles, and it clicked for me, what if we could diff them instead of taking a screenshot? So I started by looking into the documentation for the Chrome DevTools protocol, which is the programmatic way of integrating with the Chrome DevTools. And I found just what I was actually looking for, which is an API called getComputedStyles for Node. Basically, it takes a DOM node, and it gives you a giant hash that you can see here that it will go on and on and on, and I'll show more detail of it in a second, but basically shows you every possible CSS property on the node you're looking at and its value. So how can we write a test around this data? So luckily for us, basically all of the work was already done because there's a gem called Ferrum that wraps that Chrome DevTools protocol and makes it easy to work with. It just took a quick PR to add support for that specific API. And now it can do computed styles. So let's use that to write a test. So first, we load a page in a browser, and then we select a test node and get its computed style. This is the actual working code using Ferrum. And if we inspect that object, we can see that it's a hash, just like we had in our DevTools earlier. And this is the computed value for every possible CSS property on the element. And finally, we can then assert against a lookup on that resulting hash. And what we now have here, that I think I'd never seen before, is a regression test for computed CSS that makes sure that this text is read, which I think is really cool. Yeah. But this is for one property, right? This is just saying, hey, is that color red? What about a more general purpose solution? And that's where we came up with the idea of style snapshots. Well, I don't have time to dig into this in much detail. We've effectively built a VCR for styles. And here's what it looks like in practice. It compares those two style hashes and nicely formats the changed values for an entire node. And these detailed test failures allow us to automate more of the visual regression testing that was previously a very manual process. So that's how we're using style diffing to make changes more safely. So what does this mean for the future? Even with everything I've shared so far, I can't say that we've made enough progress. Many of the problems that I've mentioned remain unsolved, if not, honestly, much worse than when I even started writing this talk. You may notice, if you looked very closely, very, very closely, that more custom CSS was actually added in the past year. And it's hard to say this, but maybe our efforts just haven't been enough. These approaches, while I think they're interesting and fun to talk about, might not be viable. One common thread through this work has been really exploring the history of all of our attempts in various forms to reckon with this technical debt. To clean it up, to refactor it, and even with plenty of time and resources, I mean, I can tell you that we had 6 people working on this about full time for a year, to give you an idea. We've really fallen short. It's been really time consuming. It's been costly. The cost to refactor our CSS has proven to be so much higher than any other code that we write at GitHub. And to be quite honest with you, it hasn't been cost effective. It's been unsustainable, which means we have to do something else. And our best answer has been to rewrite. So instead of trying to wrestle with all of that custom CSS, we're focusing on rebuilding our UI using our design system, basically from scratch on a page-by-page basis. And we've come a long way. Some of you might have seen that we've extracted almost 50 open source view components for our design system. There are many more coming as well. So this is what we imagine the future of building UI in Rails, at least at GitHub, needs to look like. We need to move away from writing custom, hard-to-maintain CSS. It reminds me of one of my favorite engineering memes of all time about these 2 O'Reilly books. What would it look like to bring the same mindset to how we work with CSS? There are a lot of potential solutions. It might need more than one solution, a collection or a toolbox of solutions. But I'm pretty confident that what we have today isn't the best answer. What I hope we can do is to continue to learn from each other's experiences and from other approaches in the greater industry, because truly great ideas should not be conflated with the technologies they are implemented in. Ideas can transcend frameworks and even languages, and we're going to need the greatest ideas from wherever they come from if we're ever going to break up with our bundle. Thank you.